Ladies and gentlemen, hello and welcome, coming to you once again, not quite live, from One Take Studios, where today's topic is angles of rotation. Angles of rotation. Notice it's L-E, not E-L. We're not talking about angels, all right? That's something else. But, oh my gosh, trigonometry is beautiful, and here is the foundation that allows us to kind of branch out into a whole bunch of different stuff. So a lot of things today, a lot of little things, but very important things. All right, so angles of rotation, first of all. It is possible to graph, yes, I said graph an angle in what's called standard position. Standard position for an angle is defined as having the initial side on the positive x-axis. You got that, right? Yeah. What's an angle made up of? Two rays. All right, so what they're saying is that the initial, the beginning, the first ray is on the positive x-axis. X-axis, positive. Oh, we can do that. We'll do an example here in a second. And the angle ends at the terminal side. Terminal. Terminate. Arnold Schwarzenegger. What does he do? Brings people to their ends. This is the ending side. We have the starting side and the ending side of an angle. Interesting, but not tragic. So let's say that we would like to draw a 60-degree angle, and specifically we would like to draw it in standard position. What are we saying? Well, we are saying that the first side, the first ray, is going to be on the positive x-axis. Ladies and gents, that's right there. I know it's a little hard to see. I'll try to raise the red a little bit for you. That's it. This is the x-axis. That's the positive part. That's the first ray. To make 60 degrees, where did my second ray go? Well, this is 0. This is 90. And 60 is between 0 and 90, about 2/3 of the way through. Is anybody going to be grabbing their protractor and checking your measurements? Probably not. But does your angle need to make sense as far as location? Yes. If you draw 60 degrees down here, that's a problem. We started here, we ended here. Notice what I just did. We started here, we ended here. That is my directional arrow that says this was my initial side, that's my terminal side, that's where I stopped, and that's 60 degrees. That is what an angle in standard position looks like. So let's try again. What would this look like for 215 degrees? 215 degrees. Pause, take a moment. Where would you put the initial side? Where would you put the terminal side? Think about that. Okay, so initial side is still going to be positive x-axis, so we're talking right there. 215, that's 90, that's 180, that's 270. Where is 215? That's about 35 degrees past 180, so not quite in the middle. So I'm going to draw it here, which is not quite in the middle. Again, this is a sketch, but that is a reasonable location to be putting my terminal side. Did you forget the directional arrow? We started here, we stopped here. That little arrow doodad has got to be there. That's part of the picture. All right, so that's 215 degrees. We're actually going to draw it 4 angles because there's a reason for it that hopefully you should see here shortly. So thinking about what we've done so far, 460 degrees. 460 degrees. Ooh, fascinating, fascinating. Whatever shall you do? Is that even possible? 460 degrees? Because, again, if standard position, I start right here, great. Where is 460? Because a full circle is 360. What if I just kept going? A full circle is 360, and then if I went another 100 past that, that's 90, so that would be about 100-ish right there. Think about what just happened. We started here, we went all the way around, we kept going, and then we landed. Ladies and gentlemen, that is what a 460-degree angle would look like. And again, that makes sense as to why we have to have those directional arrows. They also tell us how many circles we've gone around to reach our desired angle. So 460 degrees is all the way around, and then an additional 100 degrees. What does that mean for negative 150 degrees? Draw that one. What are you thinking? Is it even possible? Can you have a negative angle? I say yes. If you think about this as direction. This arrow went up. This arrow went up. This arrow went up. 2 guesses as how to make a negative 150-degree angle. We're still going to start initial side on the positive x-axis. This would be negative 90. Yes, this would be negative 180, so we want to be just shy of that. 30 degrees, about there-ish, something like that. And we went down instead of up. Ladies and gentlemen, that is what a negative 150-degree angle looks like. It's all about direction. Okay? All right, something else on this topic, the idea of coterminal angles. Again, words have meanings. Prefix co means to share or to be with, and so we're talking coterminal angles share a terminal side. So we drew 60 degrees over here. What's going to be coterminal with 60 degrees? Can I come up with another angle, essentially, that has its terminal side right here? That's what 60 looks like. How do I get something that looks like 60 but isn't 60? What if, keeping in mind the last one we just did here, what if I went down? What if I started on my initial side and went down and around and back this direction? That would still have the terminal side in the same spot. Can you see that? That's a lighter green. Down, around, and stop. It has the terminal side in the same spot, so it looks like this one, but different direction and different length then, because if this was 60 degrees up, what is this? This is down, and we're going 300 degrees, so that the terminal side ends up in the same spot. Reinforce that a little bit. Sorry about the green. All right, so that would be an example of a negative angle that is coterminal with 60 degrees. Again, it has its terminal side, same spot, but we went down 300 degrees instead of going up 60 degrees. Can you come up with another one? Think about what happened here. What if we go a forward direction this time, so we'll go with red. What if we go with the forward direction, but we don't stop on the first time? What if we keep going until we stop on the second time around? So we went up, but we kept going past 60, did a full extra lap. So we did 60 plus another 60. Oops, sorry, another 360, right? That's 420, isn't it? 420. Every once in a while, my brain stops working. I'm going to double check. 360 plus 60. Oh, good. It is 420. Excellent. So a negative 300 degree angle and a positive 420 degree angle are both coterminal with 60 degrees. They have the terminal side in that same spot, but we have extra spirals in different directions. How many of these can we create? 5,362,000 or more, because I can keep spinning. I can keep spinning circles negative, and I can keep spinning circles positive, so I can come up with an infinite number of coterminal angles for any given angle. Okay, now, next concept. Oh my gosh, this is gigundous, people. This is just major. All right, are you ready? Okay, here we go. Reference angles. These make pretty much all of trigonometry possible because it's going to take us from our right triangles and make it a lot more flexible for a whole bunch of different types of angles. Reference angles must be positive. They must be acute. And they must be formed by the terminal side and the x-axis. I actually numbered these because people usually leave one or more of them out. They have to be positive, they have to be acute, and they have to be formed by the terminal side and the x-axis. X-axis. Gee, you think people forget that on occasion? I bet they do. All right, so let's think about this. What would this mean? A reference angle for 135 degrees. Okay, 135 degrees is positive. It's not acute, so let's sketch this, shall we? Let's take a look at where this would be. I find visuals to be very helpful. So again, we're just doing a brief sketch with this. We're talking initial side is here, positive x-axis. 135, this is 90, that's going to be 45 past, so we're talking that's like right smack dab in the middle over here. All right, so that goes right smack dab in the middle. And 135 degrees starts here and stops here. All right, that's 135 degrees. I need something that is positive, acute, and formed by the terminal side and the x-axis. Ladies and gentlemen, that's the terminal side, that's the x-axis. I'm looking at this dude right here, between the terminal side and the x-axis. Is that going to be acute? Yes. Can it be positive? Sure, why not? If this is 135 degrees thus far around and this is 180, how far are these apart? 45 degrees. 45 degrees is the reference angle for 135 degrees. Why is this important? Just for the fun of it, I'm grabbing my calculator. If you can't see it, I'll make sure that I read it to you. But let's say that I go with my trig buttons. I'm going the sine of 45 degrees. The sine of 45 degrees is 0.707. Can you read that? Maybe, maybe not. There we go. And what if I do the same thing, but this time I do the sine of not 45, but the sine of 135 degrees? Oh my gosh, guys, that's the exact same value. What does this mean? 45 degrees could be an angle in a right triangle. 135 can't possibly be an angle in a right triangle, but the 45 acts as a stand-in. It basically creates its own separate right triangle. And we can get our trig values for angles that wouldn't ordinarily be possible. All right, so reference angles, this concept is major. So this by itself is kind of tiny, but the whole idea makes so many more things possible. All right, so let's look at 105 degrees negative, reference angle for that. What do you think? What's that going to be? Reference angle for negative 105. Again, I do recommend a sketch. It helps me. Negative 105. My sketches don't even need to be accurate. That's going to be negative 90, negative 100, negative 105. So here-ish, something like that, is my terminal side. So I started here and I stopped here. All right, ladies and gentlemen. I don't like this, though. Let me make this straighter at least. There we go. Here's my terminal side, negative 105, because that's negative 90. We're going 15 past. I need to have a positive acute angle formed by the terminal side and the x-axis. How many of you just now wanted to connect back to the y-axis? That's not what's happening here. This is the x-axis with the terminal side. These are the two that are making the connection. So the question then is, what is this angle right here, this little dude? All right, because that's going to be acute. We can make them positive and connects the terminal side to the x-axis. So what is, let's see, if that's 180, that's 105. What's the difference between those? That should be 75 degrees. All right, 75 degrees. So this is going to have very similar trig values to negative 105. This is making it possible to do trigonometry with negative 105 degrees. Acute, positive, formed between terminal side and the x-axis. Now, let's go with, I think, one more set of ideas here. Oh yes, this guy right here. All right, so I want to tie in an ordered pair to this mess. You can see that I have my angle. It's in standard position, so here's my initial side, here's my terminal side, and right now what I know is one point. I have one point that is on my terminal side. What does that tell me? How much information is that? Would you believe that that's actually a ton of information? Because if this then is my angle, for the angle that I just drew, starting here, stopping here, that's my theta. Remember, theta is going to be a Greek letter. It's just a variable. I don't know how big this angle is, but I can make a triangle by dropping this line here. There's my right angle. And let's see, if that's xy, how far is it from the origin to my dotted line? I have to come over x. I'm going to do this in red just so it pops out a little bit more. This has a distance of x from here to here. And from here up to my point, how far is that? That has a distance of y. So by having the ordered pair xy, I now have two sides of my right triangle. Could I come up with a third side? I'm going to say yes. Let's find a label for this third side though, shall we? All right, so think about what we've been doing as far as all of our angles here, and we have a whole lot of spinning going on, yes? So imagine taking this point and grabbing it and pretending it's on a spinner and twisting. That would make a circle, and this would be the radius. We're going to call this r, all right? From there to there, it's going to be r. So, what's the relationship between x, y, and r? Well, we happen to know the delightful Pythagorean theorem, where a squared plus b squared equals c squared. Well, let's translate that into what we've got going on here. A and b are the legs, so that actually means we've got x squared plus y squared equals, what's my hypotenuse? R squared. So this right here is the relationship between x, y, and r for my triangle. That means, again, if I have one ordered pair, x and y, I've got two sides of my triangle, and I've got enough information to find the third side. So now I have all three measurements. What does this allow me to do? I can start working with my trig values. Oops, I'll come back to that one in a second. So, that means that we're going to work in just general statements for a moment here. Notice I have sine of theta. Again, theta's got to be there. because that gives us the you are here. That gives us the perspective on our triangle. Sine was going to be SOHCAHTOA. Sine is opposite over hypotenuse. If we are here, opposite is y, hypotenuse is r. So this is going to be y over r. Cosine, you are here. Cosine is adjacent over hypotenuse. That's going to be x over r. Tangent. Tangent is opposite over adjacent. That's going to be y over x. So again, now by having one single ordered pair, I can find all of my trig values for that angle. Have the ordered pair, find r, make my triangles opposite, adjacent, hypotenuse, you got it. Do you remember the reciprocals? Sine has a reciprocal. Its reciprocal is cosecant. You remembered that, right? Which means cosecant is going to be r over y. Reciprocal. Literally, flip it over. Cosine's reciprocal is secant. Again, secant of theta is going to be, flip it over, r over x. And tangent's reciprocal is cotangent of theta, which is going to be x over y. Ladies and gentlemen, this right here is some really useful information, believe it or not. It just pops up in a lot of different places. So feel free to decorate that, put that someplace in your notes where you can find it and refer to it. I don't actually recommend memorizing a whole lot of things, but if you're doing a lot of trig, I might actually recommend memorizing these first three. All right, sine is y over r, cosine is x over r, tangent is y over x. I have one last thing. What does this mean then in terms of the ordered pair -3, 4? I specifically am introducing a negative because we haven't really connected the dots on that one yet, so to speak. -3, 4. Think about location. -3, 4. -3, 4. That's going to be like here-ish. I'm estimating. It's a sketch. That means we are here. So tying together the things that we've just talked about, my theta is here. That's my theta. That doesn't make a triangle nice and neat the way that one did. But what did we just finish talking about? Reference angles. We're going to use this triangle as our right triangle. And we still have x and y and r. The only difference with it being negative is that my x value is actually negative. So this refers to a direction. So if I would like to find, I'm going to go with cosine because it makes sense for what I'm talking about right now. If I would like to know the value for the cosine of theta, cosine is going to be x over r. X in this case is a -3 over r. By the way, that's a 3, 4, 5 triangle, right? I gave you something nice and easy. That means your hypotenuse here, or the radius, is going to be 5. That is going to be the cosine of theta, -3/5. That's its value based on that point. We could do the rest of them, but that's the idea. So the only difference between something in the first quadrant and something in any other quadrant is you just have to pay attention, because occasionally x may be negative or y may be negative. Your r value will not be negative. Don't worry about that one. Think about r is the radius. That's a positive distance, so the r will always be positive. It's only the x and the y that may be negative on occasion, depending on the quadrant that you're in. So reference angles make everything possible. All right, this is a lot to digest. You're going to have to play with it. You're going to have to keep working with it. But do so. It's worth it. Trig is beautiful, guys. It really is.